I'm here to assist you with all your test equipment needs, from multimeters and test weights to patient simulators and x-ray analyzers. If you need guidance or you have any questions, please don't hesitate to write me at jbarber@bcgroupinternational.com.
What's going on, everyone? Welcome back to Better Biomed. Folks, today I'm going to take something apart, and that's why I'm wearing the safety goggles and the hat, because the things that we're going to take apart today are things that can go spring a sprung and fly all around the room. And today we're going to take some of these circuit breakers apart. We're going to find out exactly what's going on inside them. I've got two of them because I just had two failures over here in my electrical cabinet, and that is why I lost some of my air conditioning in my house. These are double pole 50 amp circuit breakers, so they're pretty big, and you can see that there is discoloration on both of them, particularly on one side. See that? I'm gonna go ahead and put you guys on the overhead camera. We're gonna take a look at it. Here we go. All right, guys. Oh man, this comes in nice and crystal clear. I dig this. I got a nice new camera here, and I got my camera up here focused perfectly. You can see the discoloration that we have right there. Interestingly enough, this guy here, you can see some hot spots that are occurring on the inside. Now, circuit breakers are actually commodity items that are held together by rivets. So in order to open them up and explore them, you have to be careful, for one, and for two, they're all held together by rivets, so you have to drill them. And I've drilled all these. They might give me a little bit of a hard time to open them, but maybe not, because I think these rivets should just push right out at this point. So on both of these guys right here, one of them had a problem with the contact being open. Yeah, this one here is the one that had the contact that was open on the black wire. Now these are 240 volt, so they hold L1 and L2, and it would be L1 that was slightly open. And the reason I changed it out is because once there is a little bit of carbonizing up in here on the contact, then at that point, it's just going to escalate. Even if I replace the conductor, it's going to happen to the next one too, at a higher likelihood. So because of that, I just changed out the breaker. They're like 20 bucks, right? But it's always cool to open them up and to explore. And as part of my rules of repair, I always say, time permitting, you should always explore the failure to see what caused it to try and prevent it happening again. Now, one of the things that I've noticed on both of these, notice right here, especially on the one that is discolored from clear amounts of more current than the other lead 2, look at how it is open wider on this one. And it's like that on both of them. You see that? Now, I should actually have a micrometer to measure, but I can also measure with this little fork tool how far in it goes. Look at it. That's how far in it goes on that one. This one here just kind of buries. So definitely the L1 conductor is not sitting as tight against the bus bar in the panel. So that's interesting. Now I'm gonna try and pull these rivets out as best I can without cutting my hands all up. They're still fighting me a little bit. Okay, there we go. Now, there are springs and such inside these, so if you ever try to open them up, you got to be really careful, because they will fly apart, and that is why I'm wearing the safety goggles. The safety squints. Yeah, this guy is definitely fighting me. All right. Well, that should be wide enough for me to open part of it. Go. Now, circuit breakers are made out of a composite material, which is a little bit wild because the composite material itself is kind of like Bakelite. I don't know if that's what it is, but it's like they haven't changed that material in many years. Wow, come on. Well, this breaker is being a little pain. You see the spacers that hold them together. Okay, you can see this particular breaker still has a reasonable amount of spring tension. This other one is not the case. It's just kind of flops back and forth. All right, so this one should be able to just separate it. I've got a couple small little guys right here. We'll probably just break it. Yeah. I wanted to be nice and dainty about it, but some of these smaller rivets are just a pain. Let's see, I got one more right here. There we go. Okay, so you can see the material, obviously, because it's not conductive and because it's fireproof, it's this weird composite. If you guys know what that material is, let me know. I'm curious. General Electric, these ones are made in Singapore. It says 40 C. Is that 40 degrees C? Come on. I've got one right there. I've got one rivet that's really holding me up. Okay, this is a cool view so we can see what's going on. Okay, so here's the screw down terminal right here. And let's see, ooh, that's interesting. So this fastener is actually capped off with like a ceramic. See that? So right above this guy, it's capped off with a ceramic. That's weird, and that's what was just chipping and falling out. So right here we have a wire that goes down, and I know that there is also a bimetallic material in there. Ooh, wow, it's falling apart. You can see all the arcy sparking that was happening inside it. Let's bring you guys down closer so y'all can take a look. There we go. Okay. So you can see the discoloration from heavy use. Now this guy right here, the concept is that when you switch it, it has a really rigid latching pattern. Like it should go clunk, right? When you click that guy on, you want it to cam, and then go wham and close. If this lever right here is just flopping around, that is not good spring tension, and that means that you have a defective breaker, right? It means it's wore, it's had some heat damage. You can see one of my contact points right here. This guy is very arcy sparked. Take a look at that. Not good at all. And is this my other wear surface? I think it is. Notice how it also kind of acts like a spark arrestor. See how it's kind of like keeps it captive in this little shield? Yeah, oh, look at the carbon coming out of there. So here's the armature that latches and unlatches it. Now, I do know that there's a bimetallic that's normally in there. And when it heats up, it actually creates a reverse bias, I believe is the correct term that you want to say. And it delatches. So if it's on, that little spring kind of warms up and it flips in the opposite direction because it's a bimetallic strip, which means one metal is going to expand faster than the other when it starts getting hot, and it's going to create a curve. So it's normally either convex or it's straight, and when it heats up, then it goes and it latches in the opposite direction, and that bias is what releases this guy, and it causes it to spring into a tripped position, which is normally this midway position. So if you have any breakers that look like that in a midway position, you know that they're tripped, and the only way to reset the breaker is you have to go to off and then go on. Yeah, this guy, you can see why it's discolored inside. It's because of high wear and tear. These springs do fatigue and these springs do get tired. And look at that wire. That wire has definitely had some better days. Let's pull the rest of this guy out. Look at this. So there's one preload spring right here, and then there's another one right there, because you want those contacts to slam together, and then when it trips, you want a spring to be able to pull it apart. See that? flush all these guys off to the side. Now the terminal itself, let's see, is this the terminal that was damaged? Well, separate. There's that ceramic on that little Phillips head screw right there that's holding this breaker together. Oh, there's part of the spring is sprung. Okay. Interesting. So these say 50T. And I'm kind of curious because inside the breaker, I believe it's also going to have a fuse. And with this being labeled 50T, I'm curious, is that related to the spring pressure or is that related to the current before it blows itself open? Because there is going to be one, fail-safe at the very end of this. And part of these, one of these is going to blow open. So it's either going to be that braided wire, but I believe that braided wire is meant for the travel, you know, because this guy is going to be moving back and forth. So you got to have a flexible component, but there's also almost definitely going to be a rigid component that's going to be the fuse. I don't know. Okay, so this terminal block looks fine. Still had a lot of damage from amperage. So this guy right here, I can see a little bit of arcy spark where it connects to the bus. So right in there. Definitely was not in the best of the condition. Now this house is a 20-year-old house, folks, so breakers, especially breakers that handle a lot of current, they're going to fail eventually. It's a moving component, and all mechanical components eventually fail. Now, what's interesting is these two are linked together by what looks like a piece of bamboo. It's, I guess, whatever works, right? Because it's not going to carry current from one to the next if something fails. It looks like bamboo. It has like a wood grain. All right, that's cool. And I've got these stupid guys right here that I'm going to have a hell of a time to try and break off. Darn it. All right, I got just the thing. Oh, yes. Here we go. When in doubt, pull out your surgical grade cutters. There we go. Another reason to wear safety squints. Right. Well, that was easy. You can see that there's also a spring that forces these contacts to close as much as possible on the bus bar. All right, let's put this guy over here. All right. And again, those stupid little rivets are a pain. I'm gonna have to break them. There it goes. And the second one's up in here. This one is definitely fighting me more than the last one, folks. Guaranteed. Wow. Okay, there we go. Oh, geez. The little rivets are incredibly strong, guys. Okay. Come on out of there. Wow. Look how strong that material is. Just incredible. Come on. There we go. Okay. So here is the little spring. This tiny little guy right here is the one that forces these contacts closed. Now take a look right here. This is the contact that connects directly to the bus bar. Look how toasty that guy is. That is really bad. So as it gets more pitted, it's going to create more arcy spark, and it's going to get exponentially worse. So right here is that thing I said before that acts as the spark shield that kind of contains the spark between the two contact points. You can see right there how it actually works. So this contact right here sits here. The shield sits right here. It kind of keeps everything contained. There's that contact point. This guy here is like a little piece of laminate. Interesting. It's obviously not going to be conductive, and it's meant to isolate. Right here's the switch. And it activates this arm right here. So right here's the off position. You can see how it cams and opens the contact points, and then it slams it closed when you flick it to the on position. You can see how it cams and it whap. There's a little preload spring right here. You can tell by the discoloration of the spring that this guy has definitely experienced some heat, and that is why the circuit breaker feels tired when you click it back and forth. You connect, go ahead and grab an old breaker versus a new one, and you'll feel that really physical wham when it latches. You want that to happen as hard and as fast as possible so those contact points slam together. Because all the arcy sparking that happens, it creates exponentially worse problems. All right, there's that flexible cable. There's that ceramic potting that I talked about before. And this one right here is the terminal. You can actually see the discoloration. Oh, come on, camera. You can see the oxidation and discoloration right here on that moving part of the terminal block right here. So this is why I wanted to change out the whole circuit breaker. Yes, there's problems inside, but because there's physically complication on the outside. So there you go. You can see on the back cover, look at all this right here. That's a bad breaker. All right. Given how this one looks, I am definitely going to go through my other heavy duty breakers. And that would normally be if you have electric in your house, you'd have electric circuit breakers for your heating. And you'll also have circuit breakers for your dryer. And if you have an electric stove, you should have a separate circuit for your stove. And if you have sub panels, you will have circuit breakers for sub panels as well. Oh, here we go. That technique really worked. Just pulled it out a little bit. So these clippers that I'm using right here, these are used in surgery for when they're cutting stainless steel. All right, that time I shielded it. These are for cutting stainless steel pins. So what we'll have is carbide blade inserts. You got a lot of mechanical advantage. These are super nice. These are some of the nice, they probably cost hundreds of dollars, if not thousands of dollars. But yeah, it says 1/8 inch diameter pin cutters. Stainless steel made in Germany. So I know some of you guys have probably never seen anything like that before. It's like a miniature bolt cutter. And those things, when you need them, you need them. They're so nice. Okay, so there are those 2 pins. Should be able to push them out now. There it goes. There it goes. I wonder if this material is like melamine, if that's what it's called. So you guys get the gist of what's inside one of these, so I don't feel bad if I just explode it. There we go. So this one here had a failing spring, and it's much, much weaker than a brand new breaker. So with that in interest, I'm just curious if there's going to be physical evidence of a spring being discolored from heat. Okay. Oh boy, these contact points are really bad in this breaker as well. Look at that. There's even a lot of material that's clearly splashed off to the side because it is it's melted. Yeah, that contact point is melted. And the spring, this spring and the other spring are almost definitely going to be weaker, way weaker. Here, let me get this piece off so we can take a look. Right, here's the second contact point. Wow. Melted, folks. Yeah. So, that is fascinating. Well, the good thing about using, I'm not even going to open this last one. We already know what it's going to be. It's going to be melted on the inside. You can see the discoloration. So here's the cool thing. Because of the material they used, yes, it saved it from having an electrical fire because every time it archy sparks, technically it could cause a fire. Creates a lot of heat. But if you see your breakers and they are very discolored like that, especially down here at the contact points where they touch the bus bar, if you see them looking like that, then you should probably change them out. They're inexpensive. They're easy to change out. For these type of breakers right here, kill the main breaker. I know some electricians can be like, oh, you don't have to kill the mains. Kill the mains, guys. Just save yourself the hassle. So I kill the mains and then go through and you disconnect the cable from the main port. And then believe it or not, these guys just rock in and rock out. You can see how there's a lip where they latch in and pop in right there. Pretty simple, huh? Very cool stuff. Anyway, folks, I hope you enjoyed that little summary. It's clearly if there's physical signs of damages, then it should just get changed out. And that's the same way with medical equipment, folks. I know that this isn't medical, but breakers, you're going to find breakers. And the same thing in operating rooms. You're going to see them in some specialty areas of hospitals, sometimes in like PACUs and whatnot. They'll have their own breaker panel. But if you do ever see breakers that look like they're discolored, you can use infrared to diagnose breakers if they are still live. And I have a infrared camera around here someplace. I used it on another project, so it's on the other side of my shop. However, folks, you can use infrared to diagnose a breaker that might be going bad because as they're showing signs of heat damage here, it'll show up bright red on the infrared, and you know that's a problem right there. So there you have it, folks. One other interesting note is that the older breakers have a flathead terminal for your main screw down, and on the new ones, they have a square drive / flathead. I thought that was kind of cool. So square drive, it offers a lot more torque. It is this guy right here. So it is in fact a square. So square is one of the most efficient means for creating torque in a fastener because, you know, it's got some really large surfaces to grab onto that fastener, and it torqued down really well. And I know some of you are like, oh, did you get it in inch pounds to the correct amount? No, I didn't. No, I didn't. But it's torqued down, and so are my other breakers. Anyway, folks, thanks for watching. Hope you enjoyed this. If you did, give me a thumbs up, and stay tuned. I got some other videos. I'm imagining how I'm going to film them because it's some crazy content, but we'll see over the course of this weekend how that comes out. Thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.